Very good morning to all. Today we're going to see a topic about dependencies. In this session, we're going to discuss dependencies. These dependencies make some of the stalls which pipeline get affected. That means we have several type of dependencies. Based upon those dependency, handling various instructions which may create a hazards. Let me discuss one by one. First one is structural dependency. Structural dependency arises due to the resource conflict in the pipeline. This resource conflict is a situations which occur when one instruction tries to access the same resource in the same cycle itself. That means consider this diagram. In this diagram, we have instruction as well as cycles here. Cycles is 1, 2, 3, 4, 5. That means we have total number of cycles is 5 and instruction is 4. In this case, each instruction going to perform different stages. That means stages is instruction fetch, instruction decode, execute, as well as memory. So during the instruction one, first cycles get executed, second cycle is executed, third cycle is also going to execute. Simultaneously, when this instruction fetch is moved to decode, instruction 2 going to handle the fetch instruction. Similarly, when instruction moves to decode, instruction 3 fetch is going to perform it. Similarly, instruction 3 which moves to decode process, instruction 4 will going to perform it. So during up to instruction 3, the dependencies never exist. But in this case, instruction 4, when try to utilize the memory in cycles, in same cycles, 4 in the fourth cycle, instruction 1 going to utilize the memory as well as instruction 4 to utilize the memory, even though it is a fetch cycle. So this is the resource conflict. One solution is that means instead of using the memory, two instructions simultaneously, better we can use a delay operations till the memory is utilized by the either any one of the instruction, but we cannot give the priority to them. So this delay may leads to hazards. So better solution is we're going to use hard work mechanism called renaming techniques. That means we divide the memory into two independent modules used to store the instructions and the data separately, which is called as a coded module as well as data memory. Data memory. So CM will contains, that means code memory will contain all the instructions and it's going to handle all the type of instruction, and DM will going to contain all the operands that is required for the instructions. So by two separate memories, this dependencies can be rectified. Next, we're going to see about control dependencies. In control dependencies, the dependency occur due to the transfer of a control from one instruction to another instructions that are moving from one address to another address based upon the operations. Some of the instructions are branch, call, and jump. In this second, consider this instruction. I1 instruction going to complete in 100 address, and I2 going to complete the process, and it needs to perform a jump process at 250. Then it going to perform I3, but it want to complete this stage I2 completely. It move to the address at 250. Consider this diagram. In this diagram, instruction 1 it's no dependencies. Instruction 2 also has no dependencies. But while still instruction 2 is going to perform decode process, before completing it, the instruction 3 going to perform enter into third cycle. This may lead dependencies. To avoid this, to avoid this type of dependency, we need some delays. If we need some delays, means it may leads to others also. But compared to this case, time dependency in delay is very less. So that some of the techniques are be used. That means either we going to use branch predictions method. That means whether the branch is going to done or not. So based upon the prediction method, we can able to avoid this type of dependencies. Next, we're going to see about data dependencies, which will lead to data hazards. Consider this statement. instruction 1 and instruction 2 here. In this case, instruction 1, add going to perform with R1, R2 and R3 registers. Similarly, instruction 2 going to perform subtraction process with R4, R1 and R2. That means in this case, addition and subtraction going to perform it. But in this case, R1 is utilized in instruction 1 also, and R2 is utilized in instruction 1. Similarly, here, instruction R2 is written here, and R1 is also utilized here. So that in above instructions are executed in pipelined process, this may leads to data dependency. That means which means that I2 tries to read the data before I1 writes it. Therefore, I2 incorrectly gets the value, which is now old value. That means it don't get a updated values. So this may leads to hazards also. That means old values, by using the old values, either it's going to perform subtraction process means this may leads to data hazards. To avoid this type of situation, we use operand forwarding method. That means we are using the interface register to present between the stages, as well as to hold the intermediate output, so that dependency of the instruction can access the new value from the interface register directly. So this type of hazards can be eliminated. So these are the three type of hazards we have discussed here: structural hazards, data hazards, and control hazards. This three, once we eliminate these three hazards, the performance of instruction handled by the pipeline processor is much more improved. Thank you.